How will toxic perchlorates affect terraforming Mars? Imagine trying to turn Mars into a second Earth, but finding the soil packed with a dangerous chemical called perchlorate. These compounds are a big hurdle in making Mars livable. Perchlorates are chemicals that contain the perchlorate ion, which is made of one chlorine atom surrounded by four oxygen atoms. On Mars, they exist mainly as calcium and magnesium perchlorate salts, making up about 0.6% of the soil by weight. That might not sound like much, but it is enough to cause serious problems for future missions. Perchlorates are highly reactive and toxic to most life forms on Earth. They interfere with how our bodies process iodine, which is vital for thyroid health. When exposed to sunlight on Mars, perchlorates react with ultraviolet rays, creating reactive oxygen species. These are molecules that can damage cells and kill microbes very quickly. This makes the Martian surface extremely hostile to bacteria or any microbial life that might help in terraforming. This toxicity is a major obstacle because many of the biological agents scientists want to use to help transform Mars relying on microbes. Cyanobacteria, for example, are often considered for producing oxygen and supporting plant life. Some strains can tolerate perchlorates, but their growth is usually slowed down, and they experience oxidative stress. This means they won't be as effective in creating a sustainable environment. Scientists are exploring ways to deal with perchlorates during terraforming. One promising approach involves using certain Earth microbes that can break down perchlorates into harmless substances. These bacteria can survive in conditions similar to those on Mars, such as temperatures between 15 and 25 degrees Celsius during the day. Introducing these microbes into Martian soil could help reduce perchlorate levels naturally over time. Physical methods are also being considered. Washing dust off equipment and habitats can help remove perchlorates from surfaces. Using water-based techniques like reverse osmosis or photochemical methods can extract or neutralize perchlorates in soil and water. These steps are essential to protect human habitats and water supplies from contamination. Interestingly, perchlorate brines on Mars might allow liquid water to exist in certain cold conditions. This could be useful for life support and terraforming, but the toxicity of perchlorates in these brines remains a concern. Managing these chemicals will be key to making Mars safe for future explorers and settlers. In summary, perchlorates in Martian soil pose a serious challenge to terraforming because they inhibit microbial growth and create a harsh surface environment. Overcoming this will require a mix of biological cleanup, physical removal, and careful habitat design. Successfully managing perchlorates is essential for transforming Mars into a place that can support life and human presence.